tuning fork moves harmonically. A ping pong ball does not. What do I mean precisely? Well, if we look at the trace on the oscilloscope, it shows a perfectly sinusoidal wave when I hit a tuning fork. And with time, that perfectly sinusoidal wave becomes less and less and less intense, meaning that the amplitude of the sine wave decays. This sine wave describes both the motion, the oscillation of the two tines of the tuning fork as a function of space or as a function of time. But it also describes perfectly the sound wave that propagates from the tuning fork to our ears or to the microphone that I have right next to it. So the sine wave has a specific frequency, one frequency, in this case 320 hertz for this particular tuning fork, and that does not change as the amplitude decays. Let's watch it again. Let's see the number of ups and downs of these sine waves that are not going to change as the amplitude decays. We can clearly see this on the oscilloscope, and if I'm quiet, I don't disturb the sine wave. And you can see that even when it becomes barely audible, the number of crests and troughs remains the same in the sound wave. For the unharmonic rest of the world, really, or this particular ping pong ball, we're going to see that as I make it bounce on the table like this, the amplitude of the bounces gets smaller and smaller with time. And the frequency does not stay the same. The frequency goes up. We can clearly see it if we watch it, and if we can clearly hear it if we listen to the number of bounces that this makes one after another. So let's do it. And pay attention to the fact that as the amplitude becomes smaller, the time it takes for one of those oscillations is shorter and shorter. So the pitch goes up, the frequency goes up. Let's listen. Very clearly. They become more and more frequent. They become more and more shorter and shorter, I should say. The oscilloscope doesn't know what to do because this is not a periodic motion. It doesn't have a single frequency. It doesn't have a single period. Therefore, the oscilloscope can't pick up a specific frequency and only shows a bunch of nonsense. This non-harmonic motion does not have a single frequency, not a single period. Thank you. Another non-harmonic motion is that of a coin that you flip on a table or a plate, when you can hear that the period, the time it takes for one complete oscillation or rotation as these things keep falling down, gets shorter and shorter with time. Listen to it. Did you hear it? Should we try again? Let's try. Thank you.